Welcome to CSEC Chemistry Part 3 at Western STEM Academy. Today we are going to be looking at the mole and molar mass. If it's the first time you are catching us, please go ahead and hit the subscribe button. Western STEM Academy is here to present another exciting lesson for you. Go ahead, subscribe, like this video, and share with someone who will find this interesting. And leave a comment. This is going to be very interactive. We want you to go ahead and answer questions. So let's go. Get ready to dive into one of chemistry's most important concepts. The mole might sound strange, but it's the key to understanding how chemists count and measure atoms and molecules. This interactive journey will transform how you think about the invisible world of chemistry. Have you ever heard about the mole? Right? Not the mole as in the TV series, but the mole as in mole in chemistry. Let me know if you've heard about it below. Comment below and let me know. If you've not heard about it, well, you are going to be hearing a lot about the mole in this video. All right. Now, question for you. What do cookies, soda, and chemistry have in common? What do you think chemistry, cookies, and soda have in common? The perfect recipe connection. Now, just like baking the perfect batch of cookies, have you ever baked before? Right? Just like how baking the perfect batch of cookies require exact measurements, chemistry demands precise counting of atoms and molecules. You wouldn't randomly throw ingredients into a cookie dough, although some of us do, right? Chemists can't randomly mix chemicals either. You have to know what amount you need, right? Instead of cups and tablespoons that we use when we're baking, chemists use something called the mole to measure their ingredients. So already you know that when we talk about mole, we're talking about the measurement that we use to measure our atoms and our elements when we are doing things in chemistry, right? So moles, this is the measurement that we use when we are in chemistry. All right, go ahead and let me know if you're understanding so far. If you have any questions that you want to answer about the mole, let us know in the comments and we will be answering them. Now, what exactly is a mole? This is the number one question. You want to know what is a mole. Not the mole that you have on your skin, not the mole, the TV series, but what is a mole? The magic number. A mole contains exactly 6.02 times 10 to the 23 particles. That's what we call Avogadro's constant, right? Any particles work. So atoms, molecules, ions, if you count it, you can have a mole of it. Now imagine a jar containing 6.02 times 10 to the 23 jelly beans. That's 1 mole of jelly beans, right? So once we have 6.02 times 10 to the 23 particles, that's what a mole is, right? Counting atoms one by one would literally take longer than the age of the universe. You can't count them one by one. So chemists needed this brilliant shortcut to make chemistry calculations possible. Now, a fun fact is that if you had a mole of pennies, you could buy everything on earth millions of times over, right? Because it's 6.02 times 10 to the 23 particles, right? Now, understanding molar mass. What is molar mass? What do you think is the molar mass, or what's a molar mass? A molar mass is the mass of exactly 1 mole of any substance measured in grams per mole. It's like the weight of a mole, right? So the mass of exactly 1 mole of any substance measured in grams per mole. Now we're going to use carbon as an example. Carbon, it's 12 grams per mole, meaning 1 mole of carbon atoms will weigh exactly 12 grams. We're going to use water as an example. H2O, and as you know, that's the chemical formula for water, H2O. H2O equals 18 grams per mole, means 1 mole of water molecule weighs 18 grams. Now, here is the mind-blowing part. That tiny 18 grams of water, which is about 18 milliliters, that's roughly a tablespoon, which contains over, as you can see, six. And how many zeros do we have here? You go ahead and count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, right? 6.02 times 10 to the 23 water molecules, right? So that's what we have for the example of water. Now we're looking at molar mass versus relative mass. What's the difference? Relative atomic mass, which is referred to as AR, just a comparison to carbon-12. So we're comparing to the mass of a substance to the mass of carbon-12. No units, it's a ratio. Example, the molar mass or the atomic mass rather, the atomic mass, the relative atomic mass. Example, right? The relative atomic mass of carbon is 12. Now we're going to look at the molar mass. So let's look at it one more time. The relative atomic mass, it's a comparison to carbon-12. It has no units. It's basically a ratio. So the relative atomic mass of carbon is 12. So the mass, the atomic mass, while the molar mass, referred to as M, the molar mass referred to as M, it has units. This unit is grams per mole. It tells you the actual mass. Example, the molar mass of carbon equal 12 grams per mole. Think of relative atomic mass as saying this atom is 12 times heavier than a reference atom, while molar mass tells you 1 mole of this stuff weighs 12 grams on a real scale. So one, you're comparing it to carbon, right? You're comparing it, while the other one, you are literally measuring it as what it is on the scale. The numbers are the same, but the meaning is totally different. One is a comparison, the other is a measurable quantity that you can actually weigh. So that's molar mass versus relative atomic mass. What's the difference? Now we're going to look at the mole formula. This is where a lot of children, a lot of students often get into difficulties. The formula. Now, master the molar formula, the mole formula. The golden equation. This equation, please write it down. It's so important. The golden equation, right? The number of moles is equal to the mass over the molar mass. The number of moles is equal to the mass over the molar mass. Now, when we're using this equation, what we do, we first identify what we know, mass in grams and molar mass, which is from the periodic table. The periodic table will give you the atomic number, and it will also give you the mass, the molar mass of the element. That bigger number is usually the molar mass. Now, you are going to plug that into the formula. Whatever you know, plug it into the formula and divide the mass by the molar mass. And then number three, step three, when you're calculating mole equations, you're going to get your answer. Number of moles is equal your chemical counting unit. Now, flash challenge. How many moles are in How many moles are in 88 grams of carbon dioxide? Think about it. We're going to solve it together soon. How many moles are in 88 grams of carbon dioxide? So let's use these three steps. One, identify what we know, right? So we know 88 grams is the mass, right? And the molar mass, we need to find the molar mass of carbon dioxide. We identify all the elements that we're seeing in carbon dioxide. We're seeing carbon, 1 atom of carbon, and 2 atoms of oxygen. And then we can calculate the molar mass of carbon dioxide. And then we plug it into the formula, the mass, which is 88 grams, divided by the molar mass of carbon dioxide, which we are going to be calculating. So let's do that one together. Right, go ahead and comment your answer below. I want to see what your answers are. 88 grams divided by the molar mass of carbon dioxide. So you should be able to calculate the molar mass of carbon dioxide by finding the mass of carbon, the molar mass of carbon, and two atoms of oxygen. Add that together and divide the mass, 88 grams, by that number, and that will give you the number of moles. So go ahead and comment your answer below. I'm excited to see what your answers are. All right, now we are going to be looking at percentage composition by mass. Have you ever wondered what percentage of water is actually hydrogen versus oxygen? Percentage composition tells us exactly how much of each element is in a compound, right? The percentage composition, we are going to find that, right? The atomic mass times the number of atoms divided by the relative molecular mass times 100%. So what we need to do is to find the atomic mass, which is going to be from the periodic table, multiply by count, how many of that atom is in the molecule, and then divide and convert. Divide by total mass and multiply by 100. And that's how you find the percentage composition by mass. Now let's calculate an actual example. Water's composition, breaking down H2O step by step. Hydrogen, H2, two atoms, right? Times the mass, 1 grams per mole is gonna be 2 times 1 will give you 2 grams per mole. Oxygen, one atom of oxygen, the mass is 16 grams per mole. So 1 times 16 grams per mole is equal to 16 grams per mole. So the total H2O, 2 plus 16 is equal to 18 grams per mole. So first we have that 18 grams per mole. Now hydrogen, out of that 18 grams per mole as the total mass, we have 2 2 being the mass of hydrogen. So 2 over 18 times 100. And then that's how we get the answer, right? 11.1% hydrogen. And oxygen being 16 grams per mole as the total mass. 16 out of 18 times 100 is equal to 88.9%. Water is almost 90% oxygen by mass. So we're finding the percentage of each. So 90%, almost 90% of water is oxygen, right? That's why oxygen is so crucial to life, because oxygen is critical in water, right? Everywhere. We need oxygen to breathe. We need oxygen for so many things around us. What are some things that we need oxygen for? I want you to go ahead and comment some of the things that we need oxygen for in our everyday life. Now, let us look at some real world mole calculations. Time to put your skills to the test. Let's work through some examples that show how moles connect to the real world around us. Example 1, carbon. Given 12 grams of carbon, the calculation 12 grams divided by 12 grams per mole is equal to 1 mole. Results showing exactly 6.0 times 10 to the 23 carbon atoms. Examples for water, 2 moles of 2 moles of H2O. Calculations, 2 moles times the 18 grams per mole will give you 36 grams. So about 2 tablespoons of water. Example 3, sodium, 1 mole of sodium atoms. Calculation, 1 mole times 6.0 times 10 to the 23 is equal to, and then you get your answer, 6.0 times 10 to the 23 atoms. So these are just some examples of real world calculations. Now, challenge time, the CO2 calculation. Remember the flash challenge? Let's solve it. Find the molar mass of CO2. Carbon is equal to 12 grams per mole. That's the molar mass of carbon. Molar mass of CO2, carbon 12 grams per mole, oxygen 16 grams per mole, right? So carbon dioxide is going to be 12, right? Plus 2 times 16, right? Because we have two oxygen molecules in carbon dioxide and one carbon atom. So that's 12 plus 2 times 16. First, we do 2 times 16, right? And then plus 12. So go ahead and comment your answer below. So 2 times 16 is 32, and 32 plus 12 is gonna be 44. So the total molar mass of carbon dioxide is 44 grams per mole. Now we apply the formula. Number of moles is equal to mass over molar mass, or mass divided by molar mass. So the mass is gonna be 88 grams, right? Divided by the molar mass, which is 44 grams per mole. And then we get our answer. 88 grams divided by 44 grams per mole is equal to 2 moles of carbon dioxide. So the answer is 2 moles. Did you get that? Comment below if you got it right. How many persons got it correct? Amazing fact. Those 2 moles contain 1.2 times 10 to the 24 carbon dioxide molecules, more molecules than there are grains of sands on Earth. Let me say that again. Those 2 moles will contain 1.2 times 10 to the 24 carbon dioxide molecules, more molecules than there are grains of sand on Earth. That's amazing. Chemistry is just simply amazing. I love chemistry every single day. All right. Now, let me know if you're understanding so far. If you have any questions, anything you need me to go over before we look at common mistakes to avoid. Let me know. Let me know. Okay, so common mistakes to avoid. Mixing up units. You don't want to do that. You do not want to mix up units. Mixing up units. Always check. Are you using grams per mass and grams per mole for molar mass? Mismatch units will be the wrong answer. Forgetting subscripts. H2O has 2 hydrogen atoms, not one. Count carefully when calculating the molar mass, because if you don't, you're going to get the wrong answer. Rounding too early. This is a common one. Keeping extra decimal places during calculations. Round only at the very end for accuracy. Skipping the setup. Always write down what you know and what you're looking for before diving into calculations. These mistakes are totally normal when learning. The key is actually recognizing them and developing good habits early. The mole in industry. Of course, the mole is in our everyday life. It's not just a textbook concept. The mole is used by our chemists or scientists, all the persons who are dealing with anything chemistry related. There is going to be some level of mole. No, the mole isn't just for textbook. It's the foundation of billion-dollar industries. Let's see how professionals use this concept daily. Let's look at that. So if you've not yet subscribed to our channel, this is the perfect opportunity for you to hit the subscribe button. Make sure you like this video. Make sure you watch to the end as well and learn something and let us know what you have learned so far. At least this formula. What is the formula for calculating the number of moles? That's important. Now, let's look back at some moles in industry, some industries that use the mole. Pharmaceuticals, drug companies will use mole calculations to ensure exact dosages. If they don't have the mole calculations correctly, you will not get the correct dosages of the different medicines that you are actually getting, right? One wrong calculation could mean the difference between healing and harm. And of course, we know about overdosing and things like that. So the pharmaceutical industry use the mole a lot. Food science. Creating consistent flavors and textures requires precise molecular ratios. Your favorite snacks exist thanks to mole calculations. Environmental protection. Scientists actually monitor pollutants using molar concentrations, protecting our air and water by understanding molecular quantities. So the mole is used in our everyday lives to ensure safety as well as to ensure our food continues to taste good as well as also environmental protection. Let me know some other places where you think the mole is used or you know the mole is used in everyday life. Practice makes perfect, always. That's what I tell my students every day. We're going to try these quick calculations. Number one, how many moles of three, how many moles in 36 grams of water? How many moles in 36 grams of H2O water? Hint, the molar mass of water is 18 grams per mole. Shouldn't give you the hint, but go ahead. How many moles? Remember the calculation. Number of moles is equal to mass over molar mass, or mass divided by molar mass. So therefore, molar mass, the mass is 36 grams divided by the molar mass, right? Which is 18 grams per mole. So what is 36 grams divided by 18 grams per mole? Comment your answer and let me know. What's the number two? What's the mass of pause, of course, if you need to work it out, pause. What's the mass of 3 moles of sodium chloride? That's number two. What's the mass of 3 moles of sodium chloride? And hint, sodium is equal to 23 grams per mole. Chlorine is equal to 35.5 grams per mole, the molar mass. So what's the mass of 3 moles of sodium chloride? Go ahead, calculate it and put your answer below. Right, number two, write your answer. Number three, find the percentage of oxygen in carbon dioxide. Hint, use the molar mass that we calculated earlier. Work through these problems step by step. Remember, I want you to identify what you know, choose the right formula, and then check your units. That's important. Now, pause the video and work out these 3 questions and put it in the comments section. Now we're looking at the solutions to the practice problems. Problem one solution, 36 grams of water divided by 18 grams per mole is equal to 2 moles. Problem two solution, sodium chloride, 58.5 grams per mole because the mass of sodium plus the mass of chlorine. So 3 moles times 58.5 grams per mole is gonna be 175.5 grams. Now, problem three, the solution. 32 divided by 44 times 100 is equal to 72 times 7% oxygen. How did you do? Did you get all of them correct? Did you? If you got this right, you're mastering them all. If not, that's totally okay. Review the steps, go back in the video, and try again. Chemistry is about practice and persistence. Now, pro tip, I want you to create some practice problems using your compounds that you see every day, like table salt, sodium chloride, baking soda, even aspirin. Go ahead and try to do some practice problems of your own and let me know the problems that you come up with and the answers. Connecting moles to chemical reaction. Are you ready for that? Are you ready? Now, here's where the mole concept becomes incredibly powerful. It's the bridge between the microscopic world of atoms and the macroscopic world we can measure. Why moles matter? Why moles matter in reactions? Chemical reactions or chemical equations, they use the ratio of molecules that react, but we can't count individual molecules in the lab. We weigh substances instead. Chemical equations show us the ratio of molecules that react, but we can't count individual molecules in the lab. We weigh substances instead. The mole allows us to convert between mass, what we measure, molecules, what actually reacts, and of course, the volume for gases. So we also look at gases. Think of the mole as chemistry's universal translator. It speaks the language of both atoms and laboratory scales, right? So that's what the mole is all about. It's that universal translator. Now we're going to be looking at the mole and Avogadro's legacy. Let me know if you have any questions so far as we're moving to the mole and Avogadro's legacy. Avogadro. 1811, the hypothesis. Amido Avogadro proposed that equal volumes of gases contain the equal numbers of molecules. So Amido Avogadro, he proposed that equal volumes of gases contain equal numbers of molecules. In 1900s, the number scientists determined the exact number or the exact value 6.022 times 10 to the 23 particles per mole. Today, the standard Avogadro's constant is now a fundamental constant, as important as the speed of light. Anybody knows what the speed of light is? Avogadro has never actually calculated his number. That came later, but his insight about gases laid the groundwork for our understanding of the mole. Sometimes the most important discoveries take decades to fully appreciate, right? Now we're going to be looking at CSEC exam success tips. Master your chemistry exam with confidence. Formula sheet strategy. You're going to memorize the mole formula and percentage composition formula. Write them down first thing when you get your exam paper. Two, show your work. Exam CSEC examiners love to see clear steps. Even if your final answer is wrong, you actually earn partial credit for correct methodology. Unit measurement. Always, always, always include units in your calculations and final answer. Two is incomplete, right? 2 moles or 2 grams shows you understand what you're calculating. It's not 2 dumpling, 2 eggs, right? What it is that you are calculating. That is so important. And a lot of times you lose out by not having your actual unit, right? Check your reasonableness, right? Check reasonableness. If you calculate 0.01 moles but started with 100 gram of a compound, double check your work. That's likely too small. So think about it, like reason it out. Does this make sense? right? I started with a large number. How is this so small? So be realistic. You have to understand the concept of which you are working with so that you can reason it out. Now, your chemistry toolkit summary, everything you need to know. Number one, the mole formula. The number of moles is equal to mass divided by molar mass. Avogadro's constant, 6 times 10 to the 23 particles per mole. And number three, percentage formula. Part mass divided by total mass multiplied by 100 because percentage is 100 per 100. Key relationships to remember. Molar mass is equal to grams per mole and it has units. Relative mass is a unitless comparison, so relative to something else. 1 mole is equal to 6.02 times 10 to the 23 particles. And percentage composition equal parts of the whole. These four concepts are the foundation of quantitative chemistry. Master them and you will excel. You've got this. I believe in you. Practice daily if you want to be successful. Work through problems every single day, even just 10 minutes. Consistency will beat cramming. If you're doing the CSEC exam, start studying from day one. You don't want to wait until the night before the exam or 2 days before the exam. Study together, get a friend, form study groups and explain concepts with your friend or your classmates. Teach others, strengthen your own understanding. And that's something I did when I was going to school. I was practicing from day one. All my books I would write. I will get a grade one in chemistry. I was studying from day one every single day. I had study groups where we were teaching each other concepts, and those really last. Like I still remember the speed of light from studying together, and so many concepts, right? Use resources, your textbook, which I spoke about earlier, online videos, and practice exams are your best friends. Use them all. Chemistry is not about memorizing, it's about understanding patterns and relationships. The mole is your key to unlock these connections. You now have all the tools to tackle any mole related problem on your CSEC chemistry exam. Remember, every professional chemist, whether a pharmacist or a chemical engineer, they started exactly where you are now. With practice and persistence, you will actually master these concepts and be ready for whatever chemistry throws at you. Good luck, future chemist! Remember to subscribe to our channel, Western STEM Academy. Follow us on Instagram at Western STEM underscore Academy. We're also on TikTok. Send us an email, Western STEM Academy 2020 at gmail.com, or call us or WhatsApp us at 571-484-9379. Western STEM Academy is a full-time online school where we provide quality educational services for students ages 6 to 18 years old. We have classes for students from grades 1 all the way to grade 11. Excellent online classes that you can learn from any location. We also offer evening classes to select subject areas. So if you are looking for an opportunity to excel, you want extra help in chemistry or any other subject, contact us today and let's get going. We can't wait to work with you, parents and students. Remember to subscribe.